Okay, so our experiment is, like they said, we're testing it before we send it to the ISS. So we're testing how much our gears move up and down, and also air distribution within our vials.
Curbing bacterial growth, so this entire setup is for growing bacteria aboard the space station. That's all the gears, the vials, everything's for that.
An exchange procedure where we take out this here, put it in over here, and then place this.
Our experiment is called Filtration of Aerial Bacillus subtilis Microgravity. So what we will be doing is we chose Bacillus subtilis because it has a biosafety level of 1. And it's using the spray bottle to spray it through into our chambers. And we have 3 different filtration systems, also our control. So I have filter paper, and we are going to use the filter paper to calculate our results, which will not be here. It will be done at a laboratory in Houston.
A lot of it in the air, and it's settling down onto surfaces and growing into a biofilm basically. And with all the crevices and little bits and pieces on the ISS, it's really hard to clean. Plus the astronauts have things they're supposed to be doing up there.
For instance, if when this is, Ryan, do you have the motor on? Yeah. Now it's turn.
Sure. So our project for this year is Destination Pollination. That is because we saw that the astronauts have to hand pollinate all of the flowers and everything, the experiments on the ISS by hand with Q-tips. Project for this year for going up on the plane is
we've got a couple of these microcentrifuge tubes that have been shaved down. And what we've discovered is that flies really don't enjoy being in small spaces. It's really as simple as claustrophobia. So that and another motivator is how we're going to get the flies to go from point A to point B.
Caption here, release, and once the microcentrifuge tube hits the cone, the fly will then be released through the cone and the point B place, which will then...
Basically, what that means is it can rotate in 360 degrees, but all the servos that work like this.
Hi, so we're Eagle Crest HUNCH, and our experiment this year is to crystallize silver by applying an electric current to a silver nitrate solution. Went last year. So initially we're running a current via laptop through our Nessie board and a crystal on each of the negative and electrodes, sorry. Gosh, I blanked for a second. And then record them using our camera and save them for later analysis afterwards.
This is our experiment VIBE, which just stands for Vibration Isolation Box Experiment. It is encased by extruded aluminum and has a plate of Lexan that is 14 inches by 6 inches by 10 inches big.
On the inside, the 4 Lexan panels are glued together with 2 end caps, Nessie end caps, that are plastic.
And then how it works is we have these mounts 3D printed out of ABS plastic with springs in between them and the inner box. Is the memory foam vibe with 3D printed, also out of ABS mounts, epoxy to the memory foam on the inside.
We're Team Prometheus, and our project is focused around phase separation of microgravity. That will be injected for the first flight, be injected with 30 milliliters of water, and it will be continuously rotating at different speeds ranging from as this is inserted into the water tangentially as the chamber is spinning to the end of the collector, which is near the top right here, and from there, by the end of the experiment, by the end of the flight, we will compare the mass and form. So due to friction, it may be a little less, of course, but in addition to that, we also have finer control.
So we're with iSchool High, and what we have created is a system that represents the circulatory system. So on the left side over here, we have the unhealthy heart, and we have the healthy heart on the right side. We change the beats per minute or the rotation of the device in the middle that pushes the liquid out. The other side is just healthier with less beats per minute. So what we see for in our data is on the parabolas, we want to see if our flow has changed depending on the way the pressure is increased in the system. And when we get our data back, we're going to see if it's compared to the healthy heart, and then with the unhealthy heart, you can maintain the full circulatory function and give off the right reading to know if they can last long in space. And like,
oh, so our team is Governor School for Science and Technology from Hampton, Virginia, and we decided to do our testing on gecko adhesion on ISS surfaces for the clean bot we had envisioned. Because of the dust particles and the skip particles. So we really wanted to help them out in terms of having a robot that can crawl around the surfaces of the ISS and pick up those particles to the walls of the ISS. So we chose an adhesive called a dry adhesive called a gecko tape that sorely depends on van der Waals forces and a couple of other forces to